Though this year has been tough, it has been a major year for space explorations and missions. A lot of major breakthroughs occurred this year. No one would have believed that a private company would send astronauts to space, but SpaceX did. Countries sent their missions to Mars for exploring the red planet, and therefore bringing us one step closer to the dream of colonizing the red planet. Among the 8 planets in the solar system, Mars is the most similar to Earth, and is also close by. It therefore naturally becomes a high-priority target for space exploration. Mars offers a substantial and pragmatic opportunity to answer key questions concerning the existence of extraterrestrial life and the origin and evolution of the solar system, and to explore the possibility of human habitation. With the start of this new decade, a new space race has started. There is a race among countries to send their probes to Mars, and that is clear of the fact that the USA and 2 newcomers, UAE and China, have sent their spacecrafts to Mars. UAE and China will contend to become the 5th nation to reach Mars. We already have made a video about the UAE Hope mission and USA's Perseverance mission to Mars, and we have put the link in our description box. Go check them out. In this video, we will discuss the unique Chinese Mars mission Tianwen-1. Before discussing more about it, let's take a step back and discuss how the summer of Mars has been. Tianwen-1 was the second Mars mission of July 2020. The United Arab Emirates launched their Hope Mars mission on July 19, 2020, to study the Martian atmosphere and climate, which was launched by Japan's H-2A rocket. Like Tianwen-1, Hope, also known as the Emirates Mars Mission, is historic. It's the first interplanetary mission ever developed by an Arab state. And the exciting and competing summer of Mars isn't over yet. NASA successfully launched NASA's next Mars rover, the 1,040-kilogram Perseverance, on July 30th, 2020. So you might think that, why now? Why are countries competing for going to Mars? Well, this question has many reasons. We all know about the space race between the Soviet Union and United States of America during the Cold War. They sent orbiters and landers to the moon. A similar space race has started today between all the major countries and companies. It's clear that our space explorations are continuing and expanding in decades to come, and that there are many who want to see humans building new societies on Mars sometime this century. Countries that can provide technological prowess today and contribute to our understandings of Mars' terrain and atmosphere are in the running for political, military, and ideological dominance throughout the next decades of this century, just as they were in the first space race. A significant reason that this new space race has started, not only between countries but also private companies like SpaceX and Blue Origin, since the space market is now a blooming, profitable market. The clumping of launches is also because of the orbital dynamics. Earth and Mars line up properly for interplanetary missions for just a few weeks, once every 26 months, and is the main reason all these 3 launches were in the same month. The European Russian ExoMars rover was supposed to join the launch party this summer, but it suffered technical issues and now must wait until 2022. All 3 of these missions are scheduled to arrive at the Red Planet in February 2021. So when the summer of Mars ends, we'll still have a Red Planet winter to look forward to. China announced its planetary exploration program beyond the Earth-Moon system in 2016. Benefiting from the engineering heritage of China's lunar exploration program, the Chinese national strategy set Mars as the next target for planetary exploration. China's first Mars mission is named Tianwen-1 and aims to complete orbiting, landing, and roving in one mission. Earlier, China launched its mission to Mars with the help of Russia in 2011, which failed completely, unable to reach even the lower Earth orbit. The period from 2008 to 2014 was an interesting one, because the 2 Asian giants, India and China, were competing in the space race and were planning to go to Mars. With the help of Russia, China launched its first mission named Yingguo-1. In November 2011, the Russian spacecraft Phobos Grunt, destined for Mars and Phobos, was launched from Baikonur Cosmodrome, Kazakhstan on November 8, 2011, which failed later, and India then successfully reached Mars becoming the fourth nation to do so. This year, China successfully launched its Mars mission Tianwen-1 successfully, which is a unique mission compared to the previous missions. From the first space probes to fly by the planet in the 1960s to the planetary orbiters and rovers of today, the United States, Russia, Europe, Japan, and India have developed Mars exploration programs to fulfill human aspirations. And the Chinese spacecraft will face a tough competition from UAE's Hope mission for becoming the fifth nation to reach Mars. The name Tianwen-1 means question to heaven, which is taken from the name of a poem by Kuo Wan, about 340 to 278 BC, one of the greatest poets in ancient China. In the poem, Kuo Wan raises a series of questions about the sky, the stars, and natural phenomena, showing his desire for the truth, which perfectly fits this mission. As with many Mars missions, Tianwen-1 is about learning more about the red planet, and through that, for scientists to learn more about their own planet. The spacecraft was launched from the Wenchang Satellite Launch Center on Hainan Island and ejected directly into the Earth-Mars Transfer Orbit using the Long March 5 launch vehicle. China's Mars rover will probably attempt to land at a site in northeastern Mars, according to a recent paper published just days ahead of the mission's launch. The paper, which was published last week in the journal Nature Astronomy, was written by team members of China's Tianwen-1 Mars mission, which aims to send an orbiter and a lander-rover duo to the red planet. The study reveals additional details about Tianwen-1, outlining its intended landing area, science goals, and the names of instruments aboard the spacecraft. It also stresses the historic nature of the mission. Not only is Tianwen-1 China's first fully homegrown Mars mission, it's also the first to carry both a planetary orbiter and a rover. The Tianwen-1 probe, with a mass including fuel of about 5 tons, comprises an orbiter and a lander-rover composite. The orbiter will provide a relay communication link to the rover, while performing its own scientific observations for 1 Martian year. The orbit during the scientific observation stage is a polar elliptical orbit, 265 kilometers by 12,000 kilometers. The lander rover will perform a soft landing on the Martian surface some 2 to 3 months after arrival of the spacecraft, with a candidate landing site in Utopia Planitia, a huge basin formed by a large impact far back in Mars's history that was also the region where NASA's Viking 2 lander touched down in 1976. According to areas defined in earlier statements on landing areas, China had isolated a portion of the vast plain as a candidate landing area, running from Isidis Planitia to the big volcano Elysium Mons. The low elevation of the area means there will be more time and atmosphere for the entry spacecraft to slow down and safely descend to the surface. The latitude between roughly 20 and 30 degrees north is also suitable for receiving enough sunlight to power the roughly 530-pound, 240-kilogram rover. The relatively smooth surface will also be conducive for roving. The mission also benefits from the engineering heritage of China. The 240-kilogram solar-powered rover is nearly twice the mass of China's U-2 lunar rovers and is expected to be in operation for about 90 Martian days. There are 13 scientific payloads in the Tianwen-1 mission in total. The 7 instruments on board the orbiter comprise 2 cameras, the Mars Orbiting Subsurface Exploration Radar, Mars Mineralogy Spectrometer, Mars Magnetometer, Mars Ion and Neutral Particle Analyzer, and Mars Energetic Particle Analyzer. The 6 instruments installed on the rover comprise the Multi-Spectral Camera, Terrain Camera, Mars Rover Subsurface Exploration Radar, Mars Surface Composition Detector, Mars Magnetic Field Detector, and Mars Meteorology Monitor. As we already mentioned earlier, the Tianwen-1 mission is unique. You all might wonder why. Tianwen-1 is going to orbit, land, and release a rover all on the very first try, and coordinate observations with an orbiter. No other interplanetary mission has done so in the past. Even NASA has either sent orbiters or rovers, but China plans to do all the 3 together. If successful, it would signify a major technical breakthrough. Scientifically, Tianwen-1 is the most comprehensive mission to investigate the Martian morphology, geology, mineralogy, space environment, and soil and water ice distribution. The Tianwen-1 probe is expected to reach Mars around February 2021 and the scientific observation phase will start in April 2021. However, China's rover will remain attached to the orbiter for 2 to 3 months before attempting its landing, according to the paper. It will also be joined by the 2 other Mars missions, NASA's Mars 2020 Perseverance rover and the United Arab Emirates Hope Mars orbiter. The international planetary science community looks forward to these exciting missions, which will advance our knowledge of Mars to an unprecedented level. The mission takes its inspiration and benefits from the engineering heritage of China's Change Lunar Exploration Program. The Chinese rover is expected to operate for a period of about 90 Martian days, according to the official announcement. The rover is also twice the mass of China's Yutu-2 rover, which successfully landed on the far side of the moon. The Tianwen 1 orbiter will provide a relay communication link to the rover and will also perform its own scientific observations for 1 Martian year. The Tianwen 1 orbiter will provide a relay communication link to the rover while performing its own scientific observations for 1 Martian year, according to the paper. One sol is about 40 minutes longer than an Earth day. 1 Martian year is 687 Earth days. Overall, Tianwen 1 aims to take Mars's measure in a variety of ways. To be specific, the scientific objectives of Tianwen 1 include 1. To map the morphology and geological structure, 2. To investigate the surface soil characteristics and water ice distribution, 3. To analyze the surface material composition, 4. To measure the ionosphere and the characteristics of the Martian climate and environment at the surface, and 5. To perceive the physical fields, electromagnetic, gravitational, and internal structure of Mars, informed the team members of the mission. The orbiter will operate in a polar orbit in order to map Mars's morphology and geological structure, while also using the Mars Orbiting Subsurface Exploration Radar instrument to investigate soil characteristics and water ice distribution. It will also measure the ionosphere and the electromagnetic and gravitational fields. The rover will investigate the surface soil characteristics and water ice distribution with its own subsurface exploration radar. It will also analyze surface material composition and characteristics of the Martian climate and environment on the surface. Though these countries are competing to reach Mars, they will overall help humans to understand the Red Planet and fulfill the dream of colonizing Mars. Soon we might witness the first man to Mars, and we hope in the coming years we might start its colonization. The dreams are big and the journey is tough, but that's what the human civilization is about: winning and developing in every circumstance. So what do you think about the ambitious Chinese Mars mission? Will it be successful, as the mission is one of a kind? Let us know what you think in the comment section below. And don't forget to like and share the video, and subscribe to our channel and press the bell icon to remain notified of interesting videos about science and the universe.